Hello and welcome to a new video on IGCSE Physics Classified Paper 2. Today we will be discussing the concept of equilibrium. Equilibrium basically means that I have an object and the sum of forces acting on the object is zero. So for example, I have 5 newtons acting to the right and 3 newtons acting to the left, and maybe like another 2 newtons acting to the left. So what is the sum of forces acting on this object? So since these two are acting in the same direction, I can basically add them together. So I have 5 to the left and 5 to the right. So therefore, this object is similar to an object where no forces are acting whatsoever, because 5 to the right cancels out with 5 to the left. And what we call here equilibrium means that there is no net force. So what happens to the object if there is no net force acting? Does it necessarily stop moving? No, not necessarily. It will either be at rest, which means that it's not moving at all, or it will be moving with constant velocity. Either way, it has zero acceleration. So whether it is at rest or moving with constant velocity, the acceleration of the object is zero. Again, to summarize the concept of equilibrium, equilibrium means zero net force, and this implies zero acceleration. So zero acceleration does not mean that it must be at rest. It could be at rest or moving with constant velocity. This is the summary of today's concept, and this is what we will be tackling in the following questions. A boat is traveling at a steady speed in a straight line across the surface of a lake. So steady speed basically means constant speed. And constant speed means zero acceleration. And this tells us that it is in equilibrium. So there is no net force. Therefore, the correct choice here is choice D. The resultant force or the net force on the boat is zero. There is no resultant force whatsoever. So the correct choice here is choice D. Car is moving in a straight line on a level road. Its engine provides a forward force on the car. A second force of equal size acts on the car due to resistive forces. So we have a car and we have a driving force, let's call it FD. And we have a resistive force, let's call it FR maybe. And we are given that FD equals FR. What does this tell me? Again, this tells me that I have zero net force, and therefore zero acceleration. So let's look at the choices. The car changes direction must be incorrect, because if it changes direction, then it is accelerating, because acceleration depends on speed and direction. Acceleration is the change in velocity. So a change in velocity could happen through a change in speed or a change in direction. So choice A is incorrect, because there must be no change in direction and no change in speed as well. So the only correct choice here is choice B. The car moves at a constant speed. A spacecraft is traveling in space with no resultant force and no resultant moment. Which statement is correct? It is in equilibrium. This is the definition of equilibrium. Of course, its speed is not changing because there is no force, and the direction is not changing as well. It must be in equilibrium. Choice B is correct. The diagram shows an aircraft flying in a straight horizontal line at constant speed. Again, if I see the words steady speed or constant speed, I automatically translate into zero acceleration because it's also in a horizontal line, so there is no change in direction. So the acceleration is zero, and therefore the resultant force or the net force is zero. So what are the relationships between the forces? Now, since the net force is zero, this means that upwards forces must equal downwards forces. F up must equal F down. F right must equal F left. So L must equal W and T must equal D. And the correct choice here must be choice A. There cannot be any force greater than any force, otherwise the net force would not be zero. A car travels along a horizontal road at constant speed. Again, constant speed means zero acceleration, and this means zero net force. You must be able to write these conclusions automatically whenever you see the words constant speed, so that they help you answer the question without any confusion. We have three horizontal forces. The diagram shows two of these three forces. What is the size and the direction of the third horizontal force acting on the car? I'm assuming that a lot of people are going to choose B. And it's incorrect, by the way. So why are people going to choose B? Because people tend not to focus on the words so much. They will see a diagram, they will see a box maybe with 1,500 to the right and 300 to the left, and they just do the automatic cancellation and they just say we have 1,200 to the right, so choice B is correct. This is completely incorrect. This is all incorrect because you have not read the question carefully. So let's try to do it in a better way. We said constant speed means acceleration equals zero, and this tells us the net force equals zero. So we have a box. We have a force of 1,500. We have a force of 300. And we have another force that we don't know anything about so far. Where do we place the third force so that the net force is zero? So net force is zero means that forces to the right must equal forces to the left. I have 1,500 newtons to the right. So I need to add something here so that I get 1,500 newtons to the left as well. So the correct choice here would be 1,200, but to the left, not to the right. So backwards, basically. Why? Because if we were to cancel out like we did before, we would end up with a box with 1,200 to the right. So we need to add the third force so that this car is in equilibrium. So we need to add an equal force, but to the left or backwards. Hence, choice A is the correct choice. Each diagram shows all the forces acting on an object. In which diagram is the object in equilibrium? So in order to be in equilibrium, you need the sum of all forces to be zero, and you need the sum of all moments to be zero as well, and we're going to talk about that in a second. Like we said before, we don't really like forces going into an object. So let's just put this here because it's acting to the right. So we just push it through the object to the other side. Now, is this in equilibrium? No, it's not, because I have two forces acting to the right and nothing balancing them on the left. So what about choice B? Well, let's leave choice B for a while. We'll talk about it in a second, but let's talk about choice D. Now choice D, again, it has forces going into the object. So let's take this guy, put it here. Let's take this guy and put it there so that everything is going out of the object. And this guy goes here as well. You have two downward forces and you don't have any forces pushing it up. So definitely this is incorrect because the forces do not balance. Now for choice B and C, the forces balance because in B you have two upward forces and two downward forces. And in C, you just have one force in each direction and they all have the same amount. Which of these is correct? The correct choice here is choice C. And the reason is that choice B balances out in terms of forces, but does not balance in terms of moments. In case you have not taken moments yet, then wait until you do. If you've taken moments, then you should know that this force here, coupled with this force there, are going to have a turning effect on the object in the anti-clockwise direction. This object is going to rotate in the anti-clockwise direction because if they are acting on the center of the shape like this, and we sort of connect them to the center, we can see that both forces are acting in the same direction in terms of turning effect. They will both rotate the center of the object in the anti-clockwise direction. So this is incorrect because the sum of moments is not zero. You should consult the video on moments to learn more about it. So the correct choice here is choice C. Again, this is pretty much a similar question. Which object is in equilibrium? We disregard this one because they are both acting to the left. We disregard this one because they are both acting to the right. We disregard B as well because, again, due to moments, they will have the same turning effect. So if we just copy the forces so that they're moving out, this is one, and this is one, and then we connect them to the center, we see that they are both going to rotate the object in the clockwise direction. The only case where the forces are in opposite directions and cancel each other in terms of force and moment is choice A. Hence, choice A is the correct choice. Each diagram shows a metal plate with 4 parallel forces acting on it. These are the only forces acting on the plates, in which diagram is the plate in equilibrium. So let's first check where the forces themselves balance. So in terms of forces, this is okay because we have 3 to the right, 3 to the left. Again, this is okay in terms of forces. This is also okay in terms of forces. This one is not okay in terms of forces because you have 4 to the right and 3 to the left. Now let's discuss in terms of moments. So like we said, we like to have the forces pointing out. So I'm just going to change all the forces so that they're all pointing out of the object. So for choice A, we have 1 Newton here and 2 Newtons here. And we have 1 Newton in this direction. We have 2 Newtons in this direction. Now the forces are all pointing out of the object. Now, which of these are clockwise and which of these are anti-clockwise? So if we join to the center, we see that this guy is going to rotate anti-clockwise. If we join this guy to the center, this is obviously clockwise. If we join here to the center, again, this is anti-clockwise. If we join here to the center, this is clockwise. So the ones are rotating us clockwise and the twos are rotating us anti-clockwise. So the anti-clockwise moment will be much greater than the clockwise moment, and this is going to be incorrect as well. If you apply the same logic to B, you're going to see that the turning effect of these forces is opposite to the turning effect of these forces. So again, the 2 newtons form a bigger turning effect, and B is incorrect. So the only correct choice here is choice C, because the turning effect is going to be balanced as well. If you replace everything, so this is going to be 1, this is going to be 1, this is going to be 2 here, and this is going to be 2. And if you join here and here, you're going to see that these together form the anti-clockwise moment. So these are both anti-clockwise, whereas the other 2 are clockwise. So the sum of forces in the clockwise direction is 3, and the sum of forces in the anti-clockwise is 3. So it completely balances out. How do we do this in a more intuitive way that is easier to understand? Well, basically, the only one that definitely works, because we already said that D doesn't work because the forces don't balance. But in terms of A, B, and C, they all work in terms of forces. But the only one that definitely works is where the forces are positioned exactly opposite each other. Like we have 1 and 1 opposing each other, and 2 and 2 opposing each other. This is even if you don't understand moments at all, this is obviously the best choice because this is the one that balances the most. A is going to rotate in this direction. B is going to rotate in this direction. So again, A and B are incorrect. And the only correct choice here intuitively, without all of these drawings that I made, the only correct choice here is choice C. The diagrams show 4 identical objects. Each object is acted on only by the forces shown. Which diagram shows an object in equilibrium? Well, again, this is the same concept. B cancels, because B is rejected because the forces are not balanced. C is rejected again because the forces are not balanced because you have 10 up. And we are between A and D. Instead of complicating things with moments and so on, which of these do you think is the better choice? Is it choice A or choice D? Of course, choice D is the better choice because the 20 is in the middle between the 2 10s. In a sense, these cancel out. However, if you put 20 on the edge, you put 20 on the edge here, you're going to have a clockwise moment because of the 20 and the 10. They will work together to form a clockwise moment that is much stronger than the anti-clockwise moment produced by the other 10 newtons. However, for D, the 20 does not contribute to moments at all because it's in the middle, and you have 10 clockwise and 10 anti-clockwise, so it balances out. Again, like we said, intuitively, this is the one that is most balanced in all of the choices. And this concludes our video. I hope you found it useful. Thank you for listening in.